we're going to create a class of our own from which we can actually create or instantiate objects. So in Java, everything is a class, and everything that's created from a class is an object. You can think of a class as basically something in the real world. So think of a class of animals. There's something that all animals have in common. They have different properties in common, and the things that they do, such as sleep, eat, and breathe, are functional things that they have in common. And the same thing is true of classes in Java. So we can actually create like a book class and decide what properties and functions we want that book class to have. So I created a new project in BlueJ called Book, and I still need to create my book class. So I'm going to go ahead and create a new class called Book. And once you open that up, BlueJ automatically has some stuff pre-populated for you, but we're actually just going to start from scratch. So I'll leave the public class book. It's good practice to fill this stuff out too. So I'm going to go ahead and put, for my description, I'm going to say book class. And then we'll decide what we want a book class to have and to be able to do. And I'm just going to put Sarah Kazemi. And we'll put today's date, which happens to be July 11th, 2018. Okay, so we've got our book class. And there's three big things that we really need in order to create a class that we can create objects from. And you can remember these as the big three because you pretty much need them. The first thing that you need are instance variables. And I'm going to put here specifically that these should be private. And we'll talk about what the difference between public and private and when you would want to use one over the other more. But basically private means that it's only accessible from within this class. So if I tried to access the values of these instance variables from a different class, I wouldn't be able to. The second thing that we need is a constructor. And a constructor is a special method that actually does the work in creating the object. And it does this by assigning values to the instance variables. And instance variables, kind of expand on that. Instance variables is basically just properties of that's shared by all objects in this class. All objects in this class. And we'll decide what our instance variables are going to be in just a moment. But the last thing that might be a little bit harder to understand is that we need to include a toString method. And it's actually going to be an overridden method. And what that means is that toString is actually a method that lives in the object class that is included in the default Java library. And we'll take a look at what that does in the object class in just a little bit. But basically this toString method just prints out a string. Well, actually it returns a string. A string that is related to an object. And you'll see why we should really override this, because what it produces by default really isn't that helpful or that meaningful. So let's start from the first part. So instance variables, those are going to be properties that are common among all objects in this class. So let's think about books. Well, books all have authors. They all have, let's see, authors. They have They have a page count. They have a publication year. They have different genres, so you can really get as specific as you need, or depending on the application that you're creating, some of these might not be entirely relevant. So think about applications like, for instance, the Amazon store. You have an Amazon store app on there, and these things are all quite relevant, and they might be used, you might want to see how big is this book, how long is it. I need to read a book for AP Lit, and hey, I'm going to pick the shortest one, so I'm going to pick the one that's 100 pages rather than 300 pages. These are all properties that are represented in Amazon's database. Something like Goodreads separates things by genres as well, so if a person who is interested in sci-fi, you definitely want to encode that as a property in your program. But for our purposes, since we're just learning and playing, we're just going to pick, let's just stick with the author, and let's do page count and publication year. That seems pretty good. So let's think about what type of data should we store the author's name as. So since an author's name is basically text, maybe we want to encode this as a string. Page count, we want that to be some sort of number. We have double, which represents a floating point or decimal point number, but you don't really have half pages, or at least we don't count them that way. So it's safe to use an integer or a whole number, in this case an int type. Publication year, we can also use an int or integer. So how do we go about creating these? Well, we're going to go ahead and just put the type of data, and then pick an identifier or a name that we're going to call this variable. In this case, I'm just going to put author name. In some databases or programs, you might want to separate last from first. We're just going to store the entire author name in this. And notice how I put a semicolon after this. I'm declaring this variable, but I'm not giving it a value because it's actually going to get its value assigned within the constructor. And we'll see how that works in a bit. For page count, we're just going to create an int, and we can name it page count. And again, these names that I'm picking are completely arbitrary. I could just use the X, for example, but that's not very meaningful. So when I go back and look at my code, that would be confusing. So I want to use variable names that actually relate to what they do. Last one, we're just going to do the publication year. So I'm just going to call that year. And once again, we're just declaring these variables, not initializing or assigning values to them. So this is it for step one. We've created 3 instance variables. We could have just had one, or we could have had many. We just picked 3 to play around with. So second, we're gonna have to assign these values somehow. So we want these instance variables to get values. And to do this, we use that special method called a constructor. Because this is a special method, it has a very special method signature. It always has to be public, which reminds me, I forgot to specify the access level of these instance variables. It is possible for these to stay public, but on the AP exam, they always want your instance variables to be private, and actually it's really good practice to keep them this way. You don't want others to have access to your instance variables, and it's good practice for other classes that even you write to not have access to modify these or access them directly. So you should always use the private keyword in specifying these instance variables. Now back to the constructor. We want it to be public because we're going to be constructing new objects of book type, or whatever type that you're creating, outside of this often. When you write a program, you might want to create different objects of different types, and you want to be able to use the book class and to create different book objects outside of this solitary class. So it's going to be public, and something to remember is the name of your constructor has to match the name of the class. So you can see the name of the class right here after public class book. So that means that this is just going to be public book. Now, methods can take parameters. In this case, your constructor can have 0 parameters. And in fact, if you want to compensate for the fact that maybe some code or some programmer might not pass any values at all to your constructor, you might want to create a default constructor which just initializes these 3 instance variables to some default value. So in this case, maybe we wanted to do that so that we don't get some sort of error, a null error. So maybe we want to say that author name gets unknown, page count gets 0, and end year gets something strange like 1969, which is what computers display after they reset. Okay, so now we want to create the real constructor. Not really this is just as real, but this is just a default constructor if no values get passed in. But since we have 3 instance variables here, we probably want to create a 3 argument constructor. So this is going to be our 3 arg constructor. This is our 0 arg. 0 arg constructor. And the thing about constructors is you can have as many as you want, as long as they assign values to your instance variables. So in this case, public book is going to have 3 different parameters, and they're going to match the 3 different instance variables that we have up here. So we're going to have a string, and we can call this something else just so that it's not confusing. We can say my author. We have an int. We could just call it count, and we could have another int, and we'll just call that my year. And let's just stay consistent. Okay. So now in the body of this method, what we want to do is we want to take these values, which are really just values getting passed in, and assign them to this one. So we're going to say that author name, which is our instance variable, gets the value that's passed in as my author. So again, this literally means author name gets the value of my author. And this is very important because once we exit this constructor, my author is kind of a throwaway variable, so we don't have this value anymore. So now we have it permanently stored in the instance variable in that particular book object. So we want to do the same thing with the other 2. So we're going to say page count, which is the instance variable, gets the value of the value that this passed in value, my count. And last, we're going to put year, and gets the value of my year. Okay, so we're actually done there. Now, before we move on to the overridden toString method, I want to show you what exactly happens if we don't override this. And then we're going to take a look a little bit at what the toString method in the object class actually does. So I'm going to go ahead and compile this. Oh, forgot my semicolon. Go ahead and compile that. And I'm going to create a new class here. I'm just going to call it book driver. So usually when you're going to create a program that uses a class to test it out, it's either called a driver class or client code. So remember, everything in Java is a class, but only these classes that have constructors and instance variables and overridden toStrings are classes that you can create objects from. So this here is a driver or client class. And so I'm going to create a main method And within this method, I'm going to create a brand new book object. Okay, so I'm going to create a book object. So really what I'm about to do is going to be calling code from this book class. Specifically, it's going to be calling this constructor. I'm going to be using this constructor. I'll show you how I do that. So when I want to create a new object, I have to put first the type of data. So the type of data is going to be the name of the class, so that's book. And then I'm going to put what I want to name the book. And I could just put B1, I put anything I really want. And then I'm going to use the assignment symbol, the equal sign. So book B1 gets, and here's where I could call the constructor. I need the keyword new, and then I'm going to call the constructor, which remember is just the class name again. And I want to use this 3-argument constructor, so I need to pass in three parameters that match these types. So I need a string, an int, and an int. So the first one should be author. So I'm going to put my favorite, who is Isaac Asimov. And I'm going to put number of pages is going to be like 399. Probably would have been a good idea to put the title, but it's too late now. This is just play data, and a lot of his books were like in the 50s, so I'll just put 1950. So what I've done here is I've created a new book object by specifying the data type, giving a name or an identifier, and then calling that 3-argument constructor. So this right here literally goes down to here, passes in Isaac Asimov as my author, which assigns it to author name, which remembers the instance variable, so that doesn't go away. The 399 gets passed in as my count, which then gets assigned to page count, which again is another instance variable. And the year, 1950, gets passed in as my year, which then gets assigned to year, which is our last instance variable. So now let's try to see what happens if I try to print out this object. So here's the identifier. So I'm going to try and print out what is in B1. And I want you to think about, what do you think is going to print out? Try to take a guess, and then we'll see what actually happens. So I'm going to go ahead and compile that, and I'm going to run the main method. So this is what we get, which isn't very helpful. And I'm going to show you why this happens. So let's take a look at the documentation for, this is the object class. So remember, every single class in Java, even the ones that you create, are going to inherit all the different methods that are declared in this object class. So let's go ahead and take a look at the toString. So here's toString. This is basically what it does. This is what it returns. Not super helpful at this point. It just says it returns a string representation of object. What does that mean? Well, let's take a look. Let's go ahead and click on this. It says it returns a string representation of the object. In general, it returns a string that textually represents this object. That still doesn't tell me anything. The result should be a concise but informative representation that is easy for a person to read. It is recommended that all subclasses override this method. That's exactly why we're going to override this, so that we can provide concise but informative representation of a book class. But right now, by default, it does this. What the heck does this mean? Well, this part right here gets the name of the class, which is book, which we see right here. Then it prints out an @ symbol, which is right here after book. And then this weird number that follows is actually a hex value that represents its hash code, which doesn't mean a lot to you right now, but basically it's a numeric representation of this object's location in your computer's memory. How cool is that? So this is literally telling you that, hey, this object is a book type and it's located at this place in memory. But that's not really meaningful or informative to a person who just wants to know what information does this book object hold. So that's why we're going to go ahead and we're going to override the toString method. So we're going to go back to the book class. And we're going to go to step number 3, overridden toString. And good practice is to annotate that this is actually overriding a method that comes from the superclass, which is the object class. So I'm going to go ahead and put @override. It'll totally work if you forget this annotation, but it's good practice to put it there. Okay, when you're overriding a method, you have to put the exact same method signature as it is in the superclass. So an object, this is the method signature. So we're going to copy this exactly. Public string, toString, absolutely no parameters. The good thing about using this annotation is it will actually warn you if you're not truly overriding a method. So say I accidentally forgot and I put a parameter in here, it'll say, hey, you're not actually overriding anything. What are you doing? So we're going to go ahead and copy that. We're going to put public string toString. Okay, so now we need to think about, well, what information do we actually want to print out when you print out a book object? Well, it would be cool to maybe print out the author's name, and well, basically all of this. Let's go ahead and put a title in here too, because that's a little strange not to have an author. So I'm going to go ahead and add one more private instance variable, and we're going to add a title. So let's go ahead and put title, and that's also going to be a string, private title, and that also means, I'm typoing it all over the place, that also means that we need to compensate for it here. So we're going to go ahead and assign title, we'll do that unknown, because this is, again, is our 0 argument. And we also need to provide it here in our constructor. So this is now going to be a 4 argument constructor. So we're going to have string title, my title, and then we'll go ahead and say that title gets the value of my title. Okay, so now we've gone ahead and fixed that. Maybe. Oh, gotta put the data type. There you go. And now we gotta do this. So it's yelling at me because I'm not returning anything, and this method is supposed to return a string. So because toString returns something, we need to use the keyword return. Very important, or else it's not gonna work. So let's go ahead and let's return a nice concise string. So let's say let's put the title first. So let's put my title. Let me write out what I want this to say. So basically, as an example, if I had a book called Robots of Dawn, or I guess you might be more familiar with iRobot. And then we can say by Isaac Asimov. I don't know why I'm typoing so bad right now. And then maybe we return a new line and put page count, whatever that is. I think we put 399. And then how about we have 2 lines here after the title, and then the author in parentheses we have the publication year, so 1950 in this case. Now what's important is I'm writing this out as an example, but what I'm really going to be putting instead of these values is the names of the the instance variables. So author name would go here instead of Isaac Asimov, for instance. And you'll see what I mean in just a second. So okay, it looks like I want the title first. So I'm gonna go ahead and return title, okay? And I need to put a space in between the title and the author name. I also need this word by since I'm adding that in. So I actually need an operator called the string concatenator. And it looks exactly like an addition symbol because it is. And I'm going to put a space, by space, and then plus, and now I'm going to put the author name. And let's see, what else do I have here? I have a space, open parentheses, and then I want to put the year, and close parentheses. And this is a more complicated toString. I just want it to look pretty. You could test this out with a much more simple return statement. But I just want to show you how we can kind of neatly format these things. Okay, so here's another thing that we've talked about. It's the escape character. So remember, we can use escape characters to introduce new lines, tabs, and stuff like that. We want to put a new line here. A return, you can't have two different return statements, so we need to do this all in one line. So I'm going to go ahead and put a new line right there. And now after that, I want to put page count. Oops, page count. And a colon, space, and the last thing will be the actual page count, which is represented by the variable name page count. Alright, let's see. That looks good. So now, in my book driver, I need to actually provide a title because I didn't do that last time. So let's do iRobot. Okay. And we're gonna go ahead and run this. Alright, so that looks pretty much spot on with what I wanted it, how I wanted it to display. And again, this return statement here does all the work for me by getting the value stored in title, then concatenating space by space, and then concatenating on the author name stored in this variable, then concatenating a space followed by an open parentheses, then concatenating the year of publication, then going ahead and adding or concatenating on that close parenthesis, followed by a new line, page count colon space, and then finally concatenating on that page count, which is stored in this instance variable. So I hope this example helps you understand how you can create your own data types, your own classes that can be used to create new objects, new data types in Java. And now you can go out there and try creating your own and try overriding your own toString methods in new and exciting ways that nicely represent the data that's contained within those objects.